How does macrophage dysfunction cause atherosclerosis? Imagine tiny immune cells called macrophages as the body's cleanup crew, always on the lookout for trouble. They patrol our tissues, gobbling up dead cells and harmful substances to keep everything in balance. But sometimes, these cells don't work properly, and that can lead to a serious problem called atherosclerosis. In the arteries, macrophages arrive after circulating monocytes, a type of immune cell, move into the artery wall. Once inside, they start taking in modified lipoproteins, especially oxidized low-density lipoprotein, which is a type of bad cholesterol. When macrophages absorb too much of this, they turn into foam cells. These foam cells get filled with lipids or fats and start piling up in the inner layer of the artery, called the intima. These foam cells don't just sit quietly. They release chemicals called cytokines and chemokines that cause inflammation. This inflammation attracts more immune cells to the area, which makes the plaque grow bigger. Over time, the buildup of foam cells and inflammatory signals causes the plaque to thicken and harden, narrowing the artery. Another problem happens when macrophages can't clear dead cells properly. This process is called efferocytosis. When it fails, dead cells pile up and undergo secondary necrosis, creating a large, unstable core of dead tissue inside the plaque. This necrotic core weakens the plaque's structure, making it more likely to rupture. If a plaque ruptures, it can cause a blood clot to form, blocking the artery and leading to a heart attack or stroke. Macrophages can also change their behavior based on signals they receive. When they become pro-inflammatory, known as M1 macrophages, they produce substances that worsen inflammation and tissue damage. Conversely, anti-inflammatory M2 macrophages help repair tissue and calm inflammation. Dysfunctional macrophages tend to stay in the M1 state, keeping inflammation active and making the plaque more unstable. Inside the macrophages, mitochondria, the energy powerhouses, can become damaged. This mitochondrial dysfunction increases oxidative stress, which activates more inflammatory pathways and draws in more monocytes. This creates a cycle that accelerates plaque growth. In advanced stages, macrophage death becomes a double-edged sword. Early on, dying macrophages can reduce cell numbers, but in later stages, excessive death without proper cleanup makes the plaque more fragile. Resident macrophages in the plaque also multiply, but they depend heavily on recruited monocytes to expand their numbers. In short, when macrophages don't handle lipids well, stay stuck in a pro-inflammatory state, or fail to clear dead cells, they directly contribute to the development and worsening of atherosclerosis. Improving how macrophages function, like boosting their ability to remove cholesterol and dead cells, can help slow or stop plaque growth and make arteries safer.